Testing. Excellent. Okay. I can talk much louder now. Okay, so it's a pleasure to be here at CFP. And one of the reasons why I'm so happy to come here and kind of talk about my experience is that CFP has really been a big part of my own career and the kind of the work that I've done over the last kind of 15 years in industry. So I came here at CFP 10 years ago. That was my first introduction to this community, and gave a talk about the work that we were doing at Jane Street at the time and the somewhat odd decision that we had made of going to a kind of perfectly innocent company and rewriting their infrastructure in some obscure functional programming language. And I came to CFP to kind of talk about that experience. And at the time, CFP was kind of a unique venue in that it was one of the only places that you could go to talk about this kind of work, because there just weren't that many people in industry kind of taking functional programming ideas and applying them to real applications. And there weren't natural venues for people who were doing this kind of work to come together and meet. And CFP filled that void. And in many ways, the landscape of functional programming has changed quite a lot over the years, in that there are now, in some sense, many more venues where you can go and talk to other people who are excited about functional programming. There's like the Code Mesh, Lambda, Jam, Strange Loop, like long lists of all sorts of amusingly named conferences where there are people who are really excited about programming language ideas and excited about functional programming. But the thing that I think makes CFP a kind of unique place, and really kind of more, this is really more broadly about ICFP and the kind of all the set of related workshops, is it's a place where the industrial viewpoint and the practical viewpoint and the academic viewpoint meet up. And from my perspective, that's been a very kind of productive nexus. I've really kind of made a lot of connections and a lot of friends in this broader community and learned an enormous amount from them. In some sense, I think of my experience that I kind of want to talk about today is really coming from three different pots. One of those is the experience I have in the world at Jane Street. And of course, that's kind of in some sense, like the deepest, richest, most grounding experience, like the experience of actually trying to do something at scale with significant amounts of money at stake and significant numbers of people. And that's been a very interesting and at this point, fairly extended process. When I started at Jane Street, in 2002, there were something like 30 employees. Today, there's something like 500. So it's grown quite a bit. And the depth of the reliance on functional programming technologies has only gotten greater in the years. When I started there, I was like doing a little tiny bit of OCaml on the side for some research projects, certain that the code I was writing was throwaway code. And 80,000 lines later, it turned out I wasn't going back to be an academic. And the code actually had to be kept around. And it was, by the way, terrible code. It took many years to unwind all the bad things I did at the beginning, to the kind of point where we started flipping over our production infrastructure to using OCaml, to today where we have something like 80 full-time developers who program exclusively in OCaml, maybe 150 or 200 people for whom a large part of their job is programming in OCaml. We kind of shockingly enough have all of our incoming traders and many actually people who are hired in other roles come and spend a month-long OCaml bootcamp where they have to learn how to use the Unix shell and program in Emacs and in OCaml and using our crazy monadic concurrency libraries. And like shockingly, it works. It's sort of an interesting story of its own. So anyway, that kind of experience of taking functional programming and making it actually work has been one thing that's informed me in a big way. The other one is kind of getting connected to other people who have gone off into industry to use functional programming. And there's more and more people who've done that. And I've learned a lot from what I've seen of what other people have tried and what succeeded and what hasn't. The other pot from which I feel like I've learned a lot is the pot of academic functional programming, right? I think and of course that's the thing that ICFP kind of uniquely brings to the table, is there are all these people who are involved in developing the intellectual framework under which all of these techniques come from, and in not just the intellectual framework, but actually often the actual software artifacts come out of academia. And from an industrial point of view, most academic code kind of sucks. And so it's something of a miracle, the quality of some of the language implementations that have emerged from the functional programming community. I think it's a kind of a nice mark for the amount that these people care about the kind of pragmatics of software engineering and use a lot of those ideas in their own work. So anyway, I think all three of these areas. I think Jane Street has been a very exciting place to do functional programming. I think the broader world of industrial applications has grown a lot, and the academic world has also, ICFP is the biggest it's ever been. That's also an exciting world. And so I think I kind of want to use those three perspectives to kind of say a few small lessons and observations I've gotten from that. So the first thing I want to talk about is a kind of terminological problem that we have in talking about functional programming, which is when we use the word functional programming, we're often talking about two different worlds and three core ideas that animate those worlds. And the two worlds I think of as like the descendants of Lisp and ML. Right? Lisp is the older of the two. It's the kind of functional programming language, although it wasn't that functional when it first started, invented in the 50s. And there's ML, a much more sprightly young language from the mid-70s. And I think these two languages and their descendants have been important and importantly distinct approaches to programming. And when people get up on stage and say, I use functional programming, they often mean one or the other. And it's important to understand that because the things they say about why it's valuable are different. There's a core idea that animates both, which is, or a few core ideas, this notion that you should kind of focus on using pure computation and immutable data structures and have easy access to constructs for higher order computing, right? This is the whole first class functions and all of that. That's a thing that animates both of them and is a kind of important piece of both. But then each one adds its own important independent piece. And I claim that independent pieces that are not, each one doesn't quite adopt as well as they could and should the advantage of the other. I think obviously the thing that ML brings is types. So the whole set of kind of ML related languages in Haskell and Scala and F# and OCaml and so on and so forth. The thing that distinguishes them is the type system, right? This kind of formal system of rules that enforces invariance on your code and informs how you think about and reason about that code. That's the thing that makes those languages unique and special. And from my perspective, the thing that the Lisp family really gets right is macros. You really do kind of syntactic transformations on your codes. And if you look at the two communities, I think they each kind of understand, certainly on the academic side, I feel like they each understand the value of the other's work, but don't quite manage to kind of fully integrate it. Like I look forward one day to the day that OCaml has a macro system that the Racket people won't laugh at. And similarly, that the Racket people have a type system that the ML people won't look at and see, wow, that's so much more complicated than I can understand. Right? I think that it's merging these ideas together is valuable, and I think it's one of the things that we kind of see getting better over time. I hope in my lifetime I will see OCaml have such a macro system. But it's still one of these things where I feel like there are lessons to be learned by the two sides. And it's just when you hear people talk about it, you should understand which of these worlds they're coming from if you want to really understand the things that they're saying. And in terms of the kind of, I think people have mostly come to really appreciate, as I said, like the values of the other points of view. I think when you talk to people on the ML side, they don't not have macro systems because they think they're useless or don't have great macro. They think because it's hard and they haven't yet figured out how to do it and reconcile it nicely inside a typed language, which raises some extra challenges. And I think increasingly the kind of dynamically typed functional language world, and in fact, the dynamically typed world has come to appreciate more the values of types. In fact, there's a lot of work that's come out of this community of how to kind of gradually add types into these systems, or the whole gradual type systems. And you can hardly walk around the programming world without tripping over a language that has added a syntax for type annotations. Even Python has one now. I don't know how far they've gotten in building an actual type system for it, but they started with the syntax, so you got to start somewhere. But anyway, so I think those worlds matter a lot if you want to understand kind of what happens here at ICFP. And I think another dynamic that's worth acknowledging, even though it's sometimes awkward, is actually the ML branch is ascendant here, right? If you look at the papers and look at what people are writing, the vast majority of that work is from the kind of typed family. And I think that's, some of that I think is just kind of details of how the community works, and some of it is, I feel like, there probably aren't enough voices from some of the other parts here as there kind of should be, but it's sort of useful to kind of know what the structure of the community is. So before I mentioned this idea that things have gotten a lot better, there's a lot more activity, there's also new conferences and all that, but it's actually important to remember that it's totally not popular. Functional programming is still very much a minority activity. You go around and talk to people at schools, and it's way better than it was. When I was hiring people 10 years ago, it was like a coin flip whether a graduate from a top school would have ever heard of ML or a related language. And now they've almost all heard of something in that space, and many of them have been taught it in school. But it's still an exotic, weird thing that their professors taught them and they're somewhat suspicious of. It's still not a thing that just feels like part of the ordinary fabric of the computing world. Another evidence of this is you see lots of sneaky functional programming projects. You talk to people in industry and they're like, yeah, I managed to hide this from my manager. It's it's good job. It's sort of, there's something problematic about this view of you have to kind of sneak the technology, and it indicates that there's something kind of nascent and incomplete in the kind of distribution of these ideas. And I think a thing that's worth separating is influence from popularity, which is to say functional programming has been enormously influential. Right? If you look at the design of all sorts of languages, they've been changed a lot by the ideas in functional programming. I mean, even by very old ideas like garbage collection, which landed in Lisp before it landed anywhere else, which took a mere 40 years to go mainstream. So it's quick transitions. But also generics, and you see closures in languages like Java, you see type inference showing up all over the place. Lots of technology that originated in functional languages has spread out into other languages. So that's one form of influence. Another form of influence is idioms. Right? There are all sorts of ideas about how to program that are transportable anywhere and have been transported. So lots of advice from people who work in lots of languages will point out the value of having immutable data structures. It's a kind of very common bit of wisdom. You'll see frameworks like React, right? The JavaScript world keeps on minting new JavaScript frameworks every 45 seconds, but some of the React is one of the more popular ones. It's kind of stuck, it seems to be sticking around, and it is deeply animated by kind of classical functional programming ideas. But I think that's the movement of features into other languages and the movement of ideas into people's brains, I think, is not enough. Right? First of all, when you move ideas into other languages, you only get a kind of partial reflection of them. I think there's a real difference between operating in a language which is, yay, had closures added to it, and operating in a language which was designed from the ground up for functional programming. And when the idioms move out into other places, the idioms are limited, right? And in fact, the part that gets to move out into other languages is that intersection between the ML and Lisp world, the higher order pure stuff, that you can do anywhere with the appropriate level. You can do it in C, for God's sake. You can do it, but the whole disciplines that come from things like high quality macro systems and that come from high quality type systems are just not accessible. So in some sense, I feel like we shouldn't be satisfied by the kind of current state of affairs in the way in which functional languages are used in practical circumstances. A further limitation of the way in which functional languages tend to be used in the real world is where you do go find the places where people are using well-designed functional languages for real practical purposes. The purposes are almost always the placement of lipstick on pigs, right? Which is to say, the prettying up and improving the experience of working with other kind of variously broken forms of technology. So, and impressive, awesome industrial scale lipstick on a pig projects, but still lipstick on a pig, right? I think one of if you, within the OCaml world, which I'm very familiar with, one of the more impressive places that's done this is Facebook, where they have a whole bunch of really awesome projects to make PHP better. Oh, right? And the amount of work that's been poured into PHP is kind of shocking, right? It's a company has gone in and they use that technology and you broke it, you bought it. It's their thing now, and they have to take care of it. And they do these amazing projects these kind of like the hack compiler. I remember a demo that I saw where Julien Vologuet, who's one of the main guys behind it, showed me like you do a git rebase and like changing thousands of files while their compiler is incrementally updating so fast it's done 10 milliseconds after the rebase is complete, right? It's working significantly faster than Git can write. It's pretty good, right? And it's like a big parallel camel program that does all of this stuff. But like it's the restriction to a smaller set of concerns and activities is concerning, right? I think one of my views from the work that I've done is that functional programming is a perfectly good general purpose tool, right? It can be used quite broadly for a wide variety of projects. And it's often limited, and the ways in which it's limited, I think, are connected to the academic origins of the field. Like you see it limited to compilers and DSLs and formal methods. That's like the place where you see most of it. That said, it's a thing which is, I think, improving and growing over time. If you look at, so Jane Street's one example of a sort of completely general purpose kind of place that's using functional programming. WhatsApp's use of Erlang is another kind of famous example of this. Twitter and Scala. And then there's like the people who are coming up with new languages like Apple with Swift and Mozilla with Rust are both kind of early in various ways, but still interesting places that have kind of repackaged these ideas in somewhat different ways and kind of trying to push them towards doing practical and fairly general purpose stuff. In fact, actually, Facebook itself is also has some internal projects to try and push the use of OCaml for ordinary programming rather than for kind of special purpose language kind of work. So I think this is an ongoing process, and there's progress that's been made, but it's still quite incomplete. So one of the questions is why? Like what? I'm personally deeply convinced that functional programming is great. Probably lots of you are too. And why doesn't everyone else agree? And I think there's a kind of fundamental fact that there's no evidence. You basically can't convince anybody. And for good reasons. You really can't convince anyone because there is no good way of obtaining experimental evidence about this. Imagine designing the experiment that would prove that, programming language technology A is better than programming technology B. It's like, you guys in this side are going to be randomized into the group that's doing their project in COBOL for 2 years. And no one's going to do that. The only thing that matters in programming are the things that happen with experience and scale. And you can't get experience and scale in the lab, right? The only experimental instruments that you have if you're doing stuff in a university is sophomores, right? And there's no pile of sophomores high enough to prove anything about what it's like to be an actual programmer because they're doing small things and there's a small time scale involved. So the experimental evidence is incredibly hard to come by. And in some sense, I don't think we should be surprised because I think that in some sense, the wrong expectations come from the name of our overall field. It's computer science. It's like, any field that has to call itself a science, you should be a little dubious of. And I think computer science is in many ways a kind of mathematical engineering discipline. And if you look at programming language design in particular, I think it's more of a kind of mathematical design-oriented thing. It's closer to architecture than it is to experimental physics. I think that, and so you don't get to the expectation that you're going to have scientific ways of evaluating these things because the things that are being done are too fundamentally human in nature, too fundamentally social. And I think this is actually a fundamental problem for programming language design. I think it helps explain that disturbing 40-year gap between when garbage collection was invented and when it started being used in a mainstream way. Is because it's very hard to convince people, and people are very much in their own heads, right? It's hard for them to appreciate the things that they don't understand, right? I think this is actually a general problem of it's very hard to value technology, especially programming language ideas, that you don't already deeply understand. And I think this is a serious problem for people who want to kind of push and evangelize functional programming because it's so hard to convince somebody that it's better. You can explain to them how it works, and you can show them a small example, and you can tell them, your success story. And by success stories, in some ways, this conference specializes in success stories and sometimes failure stories experience. But success stories are interesting to look at, but they're not convincing, right? Because for every one functional programming success story, there's 10 imperative programming success stories, right? And as we know, popularity it's not like you should thereby be convinced that imperative programming is right. We know that popularity is a bad guide to what to do, like see previous comment about garbage collection, right? So popularity can't be the guide. And so it's hard to convince people who haven't fully used and really experienced the ideas in question. And it's when this is not just like a thing to say about those dumb imperative programming people. It's true about all of us too. Like I've experienced this myself in ways that have been somewhat humbling. So one of my favorite experiences in this regard was at some point, a new feature was added to OCaml, generalized algebraic data types. And I was not excited. I thought, oh, this is the kind of garbage you get when you let compiler writers design your programming language. Like some like fancy schmancy type system nonsense that lets them more precisely express blah, blah, blah. I'm already sleeping. Like I'm a systems programmer. I don't care about like all sorts of fancy type system things. Like I want the better help messages and a faster compiler and better inlining and like, can we please stop working on the type system? And it turns out I was kind of wrong. Like GADTs, you know what they're really good for? Optimization. Like writing, you want to write like a thing that can process, a couple million messages a second and get a message in and out in 5 mics. You should learn how to use GADTs, which was surprising. Like I did not expect that. It turns out GADTs are a really good tool for controlling memory representation. And not a thing I'd known about and not a thing I'd understood. Another thing that was added with GADTs was good support for using existentially quantified type variables in OCaml, which like sounds about as like nerdy, pointy-headed, like what existentially, like are we in math class again? But existentially, it turns out existentially quantified type variables are really useful. And I knew what they were, and I had come to understand that, because ML didn't have them in a clean and easy to access way. OCaml didn't have them. And I had learned there's those standard ways of kind of working around it, and like, you get a record full of closures that hide the underlying thing and everything works out. And it turns out that totally sucked. Like it didn't perform very well. It was hard the code was harder to write. Existentials were much cleaner and much more natural. And I kind of had like dismissed them out of hand without really fully understanding them. And so I think this kind of highlighted to me the idea that you really want to think broadly about the other kind of ideas that are out there and try and understand and inhabit the understanding of other programming language communities. And maybe, that thing in some other language that you think isn't very valuable, maybe you should try it and try and live in those shoes for a little while and see if there's something that you can pick up and steal and bring back to your own work. Another thing people commonly like to talk about, and in particular I think people who are in this place of like trying to get functional programming used in some practical context in what they're in, is they say, we should use the right tool for the job. And the right tool for this job is, say, a functional programming language. And I have some sympathy for this idea. After all, should we use the wrong tool for the job? Right? Of course we should use the right tool for the job. But I think that the whole suggestion is in some sense animated by a kind of mistaken idea. And I think there's sort of 2 different mistaken ideas that animate it. One is the idea that we need lots of different tools because different jobs require different tools. Because there's just like we need a big complicated tool belt that you wear around your waist that like gives all the different tools you can do for solving the different jobs. And I think it turns out that's mostly a mistake in the sense that there are some, you need some variety of tools. It's not like you should use one programming language for every single thing that you do. But there are programming language techniques that are more broad spectrum than others that can solve more kinds of problems. And you're better off picking those when you can because it affects the organization that you're in. It makes that organization better. Why? Well, because you want to maximize various forms of sharing and flexibility and just kind of the power of the individual developer in the organization that you're in. And having a small number of tools that people can really develop expertise in and develop tools for, right? Your programming language is a tool, but you need tools for that tool. And so that, and develop shared standards so that people can walk into some other code base and understand how it works, right? So that people are kind of transportable between different areas. That's enormously freeing. Like something you find sometimes here is like, oh, we went off and built XYZ in language W that nobody uses. And it's great, although I have this chain tying me to that project and I can never leave because nobody else knows the language, right? Like that's awkward, and you don't want to be stuck in that situation, and it's not a thing you want for your organization. And so I think that people who are in organizations that have very strong requirements and standards on which languages they use. Google sort of is famous for having 4, right? You can program in C++, and you can program in Python, you can program in Java, and you can program in Go. And while I somewhat, and like occasionally, again, you can like hide from your managers and do something else, but like mostly that's it. And while I don't especially approve of the concrete list of choices, I think the fact that they keep it down to a small list is totally rational, right? I think if you want to have a good software engineering experience, the ability to kind of focus down on a small set of languages, I think really helps you do a better job of that. And I think that this is the kind of thing that really depends on scale. And many things about programming depend on scale. When if you start out like you're doing a small thing in a small company, and the individual speed with which you can do stuff is, in some sense, the dominant factor. It's like, what makes me comfortable, what makes me able to do my job best? And you can sort of go by that and be pretty happy for a while. But if you're going to do anything really big, significant, you need other people, right? Programming is social, it's collaborative. And as you try and increase the scale at which you're working on things, well, you need to deal with the fact that the constants shift around, the expenses change, right? You get more costs that come from interactions, right? As you have a big system with lots of pieces and lots of people involved, when you change individual pieces, right, that can break other things. And suddenly that pushes you in the direction of different choices about tools and different choices about how you organize things. And so I think it's an important thing to think about when you're picking technology, is not just what it means for you, but what it means for the overall organization. And for us, that's actually affected a lot the way that we think about how we kind of invest in not just the language that we use, but the tools surrounding it. Like over time, we've spent a lot more time and energy thinking about language tools and testing, right? And the OCaml type system is a wonderful thing, and it catches lots of bugs for you, and you can skate away with like not quite enough testing for a surprisingly long time, and we kind of did that for a while. And then over time, as things got more complicated and the stakes got higher, we're like, that was dumb. And we started really investing in other kinds of tools, and that turns out to be kind of incredibly important as you get bigger and you need to change how you behave. And by the way, the other thing that required more tools, like early on, we had like lots of functional programming people who we had hired to do the work in the functional programming language, which was great. And in fact, that's one of the advantages for us had been of using these kind of languages is, the set of functional programmers is roughly empty, but the people in that empty set are pretty good. And so there was a real advantage in hiring of pulling in high quality people by virtue of the language that we were using. But, as we got bigger, we started hiring people in more diverse ways, hiring more kids out of school who weren't already like baked in functional programmers, and also teaching people to program who weren't really by nature programmers at all, right? It turns out if you're a technical person who's capable of learning how to program badly is incredibly valuable. Like we have made a lot of money from like lots of terrible code that people have written, to solve their own narrow problem, maybe not in a kind of scalable and sustainable way, but in a way that locally worked for them and the small group of people they were working in. And you also have to change how you invest when you're trying to grow beyond like that core group of like-minded people who are there for the particular technology to a broader set of people who are there for all sorts of other reasons. And in fact, this feeds into another kind of larger kind of you broke it, you bought it phenomenon, right? So I mentioned this about Facebook, where it happened with them with PHP. So it's happened with us with OCaml, and I guess I'm also happier about that particular ownership story. But it's in some sense using a minority language. Like that's actually the hard part. You think, using functional programming in the world, that's hard. No, it's not. The functional programming part is easy. That makes your life better. The part that's hard is being a minority language, having the poorer set of tools and the poorer set of libraries and the poorer set of shared understanding that comes from being small. And when you enter into a world like this and you succeed, you sort of have bought a requirement to do something about it, right? And that's something that's happened to us, is that we kind of recognized fairly early that as our kind of use of OCaml ramped up and as the business ramped up, we needed to really invest in the broader community. And we've tried to adopt a kind of point of view of like enlightened self-interest about this, which is to say, we've tried to take the broad view that the overall community around the language is important and we need to support it, and it's important to our success, but we don't need to support it narrowly. So for example, we've spent a lot of time funding the building of infrastructure that we're never going to use. Right, so there's this great tool in OCaml, which we didn't write, but which we funded the work by OCaml Pro, which is a commercial services company, right, called Opam, which is a package manager. Before Opam, it was an embarrassing thing to have to explain to someone how to install OCaml. I remember doing a tutorial at CFP years ago where I felt like I brought out my burlap sack full of tar balls and like emptied them out on the table and said, you can probably figure this out. And we spent like the first 2 hours or something just installing stuff. It was horrible. Now Opam, you say Opam install, blah, blah, and things work. And that's transformative, but we don't use it. It has no role in our internal infrastructure. But the community has a role in our world. Like I think we've benefited an enormous amount from the work that the kind of core contributors to OCaml itself have done, and people building libraries and people building tools. All sorts of great stuff has come our way because the community is like alive and active and successful. And we try to support it by evangelizing and giving talks and releasing our own software and supporting the stuff that other people do. And I think it's worked out extraordinarily well for us. I think it's helped the community that we depend so much on become more vibrant. It's helped us hire people. And I think it's a thing I kind of recommend to organizations that are in this position. Like if you really depend on a technology, you shouldn't make an overly narrow calculation of like, well, if I spend this much money, what do I get? I don't get any product back out of it, so it's not worth it, right? It turns out, I think that these communities have a lot of value, and they'll take your concerns more seriously if you kind of openly contribute back to them. And I think it's for companies that are involved in minority languages, I think it's a really valuable kind of mindset to take. Another observation. So I was talking before about the relationship between kind of academia and industrial work, and I think that's a really productive perspective, and I think you will sometimes hear people in industry being like, academia, they're all off, heads in the sky, doing stuff that doesn't matter for practical work. And I really think this isn't true. I think that, in fact, I feel this actually about lots of academic disciplines. My own home field is distributed systems, and I feel like I learned an enormous amount from the work I did there that was of practical import. Like even though I didn't go off like writing Paxos algorithms for doing distributed consensus, nonetheless the kind of insights and intellectual organization that came from that world I found enormously informative. And I feel very much the same way about the programming language community. In fact, a thing I find kind of surprising and like mildly frustrating is how sensible the academic community is. I feel like I've been off like in industry doing practical stuff for over a decade. Like I have a lot of hard-won lessons about what's the right way of approaching things and how do you solve problems. And the degree to which I go off and talk to the sort of senior people in the programming language community about how things should be done, and the amount of like shared ideas and concepts is like surprisingly high. It's like, how did they get there? Like they're just writing compilers and like papers and stuff. Like how do they know anything about software engineering? But I think I think part of what's going on is there's a surprising the languages are kind of surprisingly kind of well fit to the problem space, which in a way which I think is sort of accidental. Like I think that Phil Water has talked about before, but I think the good programming languages were more discovered than invented. And I think the people who discovered them kind of got lucky in some sense. Like they were like, working in a good space, things that had nice mathematical structure and that kind of held together. But the fact that ML and its descendants are such good pragmatic programming languages, in some senses I think dumb luck. Like there were lots of other programming languages that people invented that turned out not to be as good. And I don't think like people sort of thought in advance and had, deep reasons to know that these were the right things. I think there was a certain amount of luck that fell in there. But in any case, I think it turns out that the academic world that thinks about these languages has a lot of practical and useful things to say. And some of it is on the design of the languages themselves, and some of it is on the ways in which you should use them and the kind of idioms that are useful. Like one thing that I've had kind of personally a very productive back and forth on with lots of people in the academic world is on kind of incremental and reactive programming, where there's a whole bunch of work that people have done about how to think about structuring incremental programs. And that turns out to be a really important pragmatic problem for a lot of different things, right? If you're building, trading systems, or you're building user interfaces, or lots of other kinds of calculations that you might want to do, this notion of having programs that can efficiently react to new information is a kind of fundamental problem. And it turns out the academic perspective on this was very valuable. And there's a system that we built internally called Incremental, where we wrote the first version without really reading the paper carefully. And we made a lot of mistakes. And going back and looking at the papers helped. And there were lots of things that we were able to fix by kind of understanding the kind of academic perspective and the ideas that people had kind of carefully thought through. It's worth saying, it's also true in the other direction. I think there's a lot that academia can learn from practitioners. I guess somehow in some of that same work, I think there were lots of semantic ideas that we got wrong in our first versions, and lots of performance ideas that the authors got wrong. And I think some of this difference in information comes from difference in focus. There are just certain kinds of problems that academics don't kind of fully have access to. Some of them have to do with exactly what problem space you're looking at. Like there are certain kinds of performance problems that academics happen not to look at, and some practitioners do care about, and that's one kind of information difference that goes the other way. Another thing that I think academics have very poor access to, in some sense, is the problems that come at scale. So when you think about how do I deal with versioning and code review and testing and various other software engineering stuff that matters when you're trying to build multi-million line code bases, there's actually very little experience in academia, and there's a whole bunch of interesting problems there that, you see previous comment about academic code is usually not that good. There's usually not that much code review involved in a lot of those things. Those infrastructures are just not ones that they've had an opportunity to kind of really dig into and understand. And so I think there's a really kind of productive space for both of these worlds to talk to each other and share information. And I think whichever side you're on, I think it's worth seeking out people from the other side. I think the other thing that academics can learn from practitioners is kind of something about what things matter, right? I think academics start out with pretty good intuitions about kind of what are reasonable ways of designing programming languages, but I think in the field, when you're using it with a large number of people and at scale, you learn all sorts of things about what things can be taught to people and what things can't, and what features are too complicated for people to use in practice, and what kind of techniques actually meld very well and are easy to show people. And I think programming languages really is, as I said, it's kind of a human-oriented design problem in addition to being a mathematical problem. And I think it's important for the academic side to pay attention to the human side, and the practitioners have most of the humans that are kind of doing programming at big scale. I think it's worth more communication there. So another kind of aspect of the kind of practical use of programming language in the real world is teaching them. And I've thought about teaching in a lot of ways in my life, sometimes literally with my own kids. I have 3 kids, all of whom I have taught on a surprisingly wide variety of different programming languages at this point. And that itself is a super exciting kind of adventure to go through. And by the way, if you want a good idea for a project to do with your kids, text adventures. I recommend text adventures. They're super fun. But there's also the issue of teaching of functional programming in schools, which I think is one of the ways in which these ideas are distributed, and I think an important thing, if you care about functional languages getting more traction and being used more and being a more kind of real part of the computational world, then you should care about the educational side of this. And I feel like the story that around this is both kind of good and improving, but also sort of tenuous, which is to say, I actually go around and have had the privilege of giving talks at a whole bunch of different universities that teach some variant of ML as part of their kind of major curriculum as a thing that everybody goes through. And there's a kind of shocking number of them, right? Brown and CMU and Cornell and Princeton and Harvard and some other, a bunch of major US universities, and a lot of universities in Europe as well, and probably other places I'm not thinking of, teach functional programming as a kind of core important part of the curriculum. But there's something sort of tenuous about the state of affairs, which is to say the functional programming itself is not necessarily widely kind of recognized and understood as a kind of important and valuable discipline. And even in departments that have very strong kind of functional programming contingents, there's often some other part of the department that looks suspiciously at the functional programming people. And the main reason I think that so many of these schools teach functional programming is because the people who care most about programming are the people who study programming languages, and they're often the ones who are willing to take the time to teach the courses. So anyway, why, like, this is sort of all academic inside baseball. Why does it matter? I think the reason it matters is if you care about the kind of language community being successful, I think you should care about how those languages are kind of useful and usable in academia. And I think that requires some real focus on tooling that can be used by people who are teaching. I think teaching languages is hard. There's lots of infrastructure to help people out, like in mainstream languages. Like you go and use Java, and you have all these kind of really awesome IDEs that help you explore things and help you find things. And like, yeah, there's a lot of boilerplate to write, but like there's a button that generates a bunch of it, and people are often made sort of happy by that. And then even separate from the concrete tools, there are other advantages that we can't have, like Stack Overflow. Like you want to know a thing about some major language, you either go to Stack Overflow and search it, and you will find like bajillions of answers. And you want to know something about a relatively obscure kind of minority language, it's a lot thinner on the ground. And you can't all at once manufacture that kind of shared knowledge base in kind of off in the web, but you can make your tools better. And I think making tools better in a way that optimizes towards learning, I think, is really helpful. And this is the thing that we've had a lot of kind of internal kind of experience and success with it as well. And that we, as I mentioned, we have this kind of OCaml bootcamp where we teach a bunch of non-programmers, some programmers and some non-programmers, but not functional programmers, to program in our world. And it's gotten massively easier over the years, and one of the reasons it's gotten easier is because we've invested a lot in the tools. And again, that's kind of an overall thing that I feel like I've learned over the years, is that tools are incredibly important. Like many good things about languages can be swamped by bad tools. If you want a good evidence for how important tools are compared to languages, look at Go, which is frankly uninspiring programming language. It was like, ideas were like fresh in 1968, but it's just like doesn't have that much to offer. But the tooling is awesome. And I know lots of people, including people who are happy functional programmers, who are like, yeah, this Go thing, it's not bad. I mean, yeah, I wish I had some higher order anything and good, parametric polymorphism and all this stuff. But you know what? The tools don't suck, and that's incredibly valuable. And I think it's easy from a kind of point of view that like values the language. It's easy to underestimate the point of view of tools. So I guess kind of one final point I want to make is that when you're off wanting to do practical things and take functional languages and make good real-world use of them, it's often tempting to focus on evangelism, on trying to convince people and trying to get other people to do things. And I think that is a hard proposition and kind of a losing game in some sense. People are hard to convince, and the world moves very slowly, right? I think getting ideas out there, I think, you can do it, and I think that this community has chipped away at it over the years and pushed forward a lot of these ideas and gotten a lot more uptake on it. But it can take sometimes like, glacial time frames, right? Again, like parametric polymorphism, mid-70s invented, hit mainstream languages 2000 and something, right? Whenever like generics hit Java. Again, like 35 years or something gap between invention and use. So while I think it's great to think long-term about how you can help spread the ideas, I think short terms, just succeed, right? These languages are incredibly valuable tools. You can use them for making your own life and your own organization better. And by doing so, you can build another one of these success stories. It won't exactly be convincing, right? As I said, success stories don't really prove anything. But they add up over time. And in the meantime, you can have like a great profitable business that does wonderful things, and you get to work with tools that don't make you want to claw your eyes out. And I think it's a kind of short-term strategy that we can all kind of take and just kind of do the thing with our own hands that makes us the most effective. And with that, I'm happy to take questions.
Hello. Hi. It's more of a comment than a question. So you mentioned that you funded Optimum, but you don't use Optimum. And you also release a lot of packages on GitHub. But have you tried building those packages using the tools that OCaml programmers have and not your internal tools? It can be quite tough, and a lot of them. I had a couple of cases where it's like, I saw a cool package on GitHub, I pull it down, and it just doesn't compile. And then I'll have to figure out, like, okay, what do I have to tweak here? What do I have to tweak there? And here's the couple of lines of code I need to delete to make it work using OCaml build or in my local environment.
Sorry, so the question is, the comment is like,
so you release a lot of packages, but do you try building them using the tools that other people will have available?
So increasingly we do, actually. There's a lot of work in the OCaml world for making kind of continuous integration testing for OPAM packages. And actually, these days, when I do like an OPAM upgrade and install our stuff, it usually works pretty smoothly, at least on the Mac, which is where I do stuff at home. And so yeah, we've been doing a lot of work to make that integration smoother. And in fact, I think the primary thing we're doing that's going to really make that really work is we've taken a bunch of our internal tools, like Django, which is a build system that we wrote internally, a fact about which I am deeply embarrassed. Like the idea that a company today should write its own build system is ridiculous. But there are no good build systems. It's sort of crazy. But anyway, so we wrote our own build system, and we've now done a bunch of work to make it usable outside, and we're going to start releasing our packages externally using the same build that we use internally. But the reason we don't use OPAM is, I think, a subtle one that I think people who work in kind of more intensely, like the kind of working on stuff that's more purely open source, often don't fully understand, which is that lots of companies, ourselves included, have found it's incredibly useful to have single, very large repositories for managing their code base. This kind of what's called a monorepo approach, which turns out to be a massively simplifying technique, and like Google and Facebook and lots of other places will do this, and we do it too. And that's incompatible with things like OPAM's workflow. And like the downside is you have to do some work to cross that impedance barrier of figuring out how to kind of push things to the open source world. The upside is you get to build your source code without ever having to say the word constraint solver, right? Which totally sucks, right? It's just a much simpler version where you can say like, what's the version of the world? This single hash tells me everything. That's an incredibly powerful kind of software engineering move.
Hi, Tyler Drombowski from Fugue. I had a question. You mentioned going from using OCaml as kind of like an experimental language in Jane Street to now it's the language in Jane Street. It's used everywhere. I was kind of wondering what it was like crossing that tipping point where you guys knew that you were invested, and especially when it comes to the tooling, being able to make the business justification of writing the tooling internally versus like moving to a language where there is that tooling already exists.
Yeah. So yeah, Jane Street's a pretty good place and a pretty rational place. And one of the things I have loved about my professional life there is that, by and large, the major work I had to do to convince other people that we needed to do something was to first convince myself. And once I had an argument that made sense to me, it was pretty easy to get other people to come on board. We didn't, like the move to OCaml was taken after like some serious thought and some discussion, and looking at statistics about how vital the community was, and thinking about like how practical of a move this was, and thinking about what other companies had done. The move to do more tooling work has been incremental and has been justified by the effects piece by piece. Like at some point you're like, oh, we're going to spend some time doing tooling, and all the people who are working are like, oh, this is so much better and I'm so much more productive. And you're like, okay, we should do more of this. And by trying to kind of rationally engage with the question of what's the best thing for the company, we're able to kind of realize that we just needed to do more of this.
So, Aaron, you talked about gathering evidence for the value of functional programming. Well, Jane Street is in a very good position to do that. But to do so convincingly, you probably need to collaborate not with people from the PL community, but with people from the empirical software engineering community. I wonder if you have any such studies going on, or whether there's an opportunity there.
So we don't have the studies going on, and I'd love to talk about this later, but I'm actually deeply dubious about this in principle. Like, I think when I look at the Jane Street experience around software engineering, I think, what better evidence is there of functional programming being great? Where we had a company which didn't use functional programming, and then we brought it in, and we had this objectively much better software infrastructure after all that work, and an incredibly successful company that really depended on that software in a fundamental way. Clearly, functional programming is great. But actually, there's no evidence at all from that, right? Because the people doing the rewrite were different people, and it was a rewrite, which is always better, even with the same, well, not always better, but you have a lot of new opportunities on a rewrite. Sometimes it's worse. And we put new people and new engineers at a different time. There's nothing like a controlled experiment here. And now you come into Jane Street today and oh my God, selection bias. We have hired differently from other organizations. We have all sorts of differences in our behavior. And I just don't know as a scientific matter how you'd construct any kind of useful empirical data from the work that we do. So I've talked some with people kind of on the side, and I've never come away with something that seemed to me like kind of technique that seemed kind of well-founded, and that thought would that if the results came out and I saw them, I would believe them. And indeed, I think this is actually a problem. Results come out and people say, oh, that one violates my prior belief, so I'm going to find ways I don't believe in this study. And I actually just don't believe in any of the studies, including the ones that confirm my beliefs, because I think social science is hard, and social sciences about things that are too expensive to do, like make large teams of people switch programming languages, seem nearly impossible.
And has science of its own.
That too.
Gleb Pergut from Google. I have a comment on the last, slide. Sorry, I didn't drink my coffee today yet, so I'll be slow. So user advantage. It works, but only if the organization you're in is not too big. If the organization is big enough, there is so much existing infrastructure without which you cannot use the tool of your choice because there is no integrations. So yes, module this slide.
That's right. Yeah, I think you're absolutely right.
There's often a chicken and egg problem if you're big enough. There is no infrastructure, you can't use the infrastructure to do good projects. There is no good projects, there is no reason for infrastructure to exist. Specifically I'm talking about Haskell at Google. This is a really tough problem.
Yeah, I think that's right. I mean, I think if you really want to be able to kind of make your own choices about technology, I think there's two things you can do, right? You can start your own place and do your own small thing and build things the way you want to, and then you can start small and build from there. Or you can do the hard, laudable work of convincing an organization to do something new. One of the reasons I'm actually kind of upset about Go as a language is not because it's a bad language, it's an okay language, but it's very rare that a company takes the opportunity to build a big new language, and it's a depressingly kind of small amount of progress to have done in that move, right? And I think that there are people in various larger companies who are trying to do the work to build institutional infrastructure for using functional programming, and I think that's great. But I think just saying, oh, I'm going to do it on my own and find a way to hide it from my manager, it's I don't think it's a good career move. I don't know. I think if you want to do well, it's great to optimize for the organization you're in, rather than just optimize for the thing that's technically the most fun for you.
So I think, as you say, I don't think you can take Jane Street to be some proof that using a functional language guarantees success, but you can take it as a proof that it doesn't guarantee failure.
I agree. And I think many people imagine that failure is the only option when using functional languages, is certainly for the kind of work that we do. I think lots of people think, well, clearly that's not going to work. And it turns out, no, actually, big successful business totally works.
Hey, Chaz Leichner from X. In terms of sort of spreading our wings conceptually, what languages do you think people in this community aren't looking at that we should? Or what systems, for that matter, to include things like Go?
So I often feel like there's insufficient communication. I think I mentioned earlier between like the typed and untyped. So I think there's a lot that the ML community, and I mean ML like, you know, in the ML and Lisp, right? I don't mean to exclude like Haskell and Scala and whatever, but I think the statically typed world could learn a lot from the things that are understood about macro systems. I think macro systems are really incredibly valuable, and learning how that works is great. I think a thing which I feel like I should learn more about is some of the kind of more proof-oriented systems, the kind of Agdas and Cox of the world, which I've learned little bits about, but I'm interested in learning more. And yeah, that's what comes to mind. I don't have like a super long list of things. It's just I kind of, in general, try and like when I learn about new things, kind of poke around and try and see how they work. And like for what it's worth, also look at like systems that you don't think are going to be great. Like I think that looking at and understanding what it is about the world of Go that's so compelling, because it really is in many ways very compelling. Looking at the JavaScript world and how they manage software and how they manage packaging, which I think is a mix of great and terrible, but I think there's some things to be learned from there. So I think some stuff within the functional programming world and some stuff from outside of it. And actually, and another thing, you should learn from like C++ and C about performance and about what are the things that C programmers do to make things go fast, and understand how you can make your language capable of doing those things. That's another, I think, important area where it's easy to get like, oh, I'm off in my like, you know, higher type dependently Lambda calculus in the sky kind of thing, and like not think about machines. And you should also think about machines.
Yaron Andrikow, Commonwealth Bank. One of the things that I grapple with is how hard to push FP in general in the context of this conversation at non-specialists. The example I'm thinking of is the machine learning community, where they really love R and Python. And the problem that we've been using the tooling as the metaphor for the things we don't have in this conversation, but in this case, like the R world is the one I look at, where like what is so exciting in R land that keeps these reasonably intelligent people doing insanely stupid things? Because you look at the code they construct, it's awful, and yet they get the outcomes they need. And so my question is where do you think? Because I know like by reputation anyway, Jane Street does a lot of work to help new hires who aren't core programmers come on board, at least to be able to share the lingua franca of working in your case, OCaml. I've tried that before in Haskell. It works really well. But I'm sort of up against the line where, like, if I go one step further, and we've got turns out a big Scala shop, okay. But if we go one further and try and get the data scientists to be doing things in a way we can put in production, it kind of implies they work in Scala or Haskell, and they're not there at the moment. And I'm sort of nervous about that. Should we be tolerating them continuing to work in R and tooling around that, or should we be trying to drag them off of R and NumPy and so on, and re-implementing the machine learning infrastructure in our languages? And I'm just curious how you feel about that class of problem.
Yeah, I mean, I think that's actually very hard. To give you a sense of why I think it's hard, like, we haven't succeeded in doing it. Like, we still use R for things because there's lots of nice integration of all sorts of little packages, and like, ecosystems are valuable, and it's hard to replicate those ecosystems. So I'm more optimistic about teaching people how to use functional programming, but taking like powerful ecosystems that have lots of built-in functionality and replacing them, like, I think that's really hard, and I think you need to have a really, like, in something I feel like you take it from the point of view like inhabiting their perspective, think about their daily workflow and think, would it really be easier in this programming language? And like, often the answer is no. Often it's just easier for them to like thwack together their R thing, and like, you know, don't recommend to people things that don't make them more effective.
Hi, Eric Torrebor, Zalando. What are the things that are coming up to OCaml maybe in the next 3, 4, 5 years that are coming from the academia into the language that you are really excited about, that's going to change your life as a practitioner? Are there?
Interesting. So a thing that has been like lots of collaboration between us and between the academic world is Lambda, which is a better inlining pass for OCaml, kind of improving OCaml's optimization. So that's, I think, an exciting thing. There's been a lot of work that's happened from outside of our walls on improving kind of IDE-like functionality in OCaml. And that kind of getting like integrated and upstream with a compiler and stuff is the thing that kind of makes the kind of day-to-day working really lovely. There's a couple, another big thing that's coming, which I'm pretty excited about, is modular implicits, which is essentially a form of type class-like functionality for ML that kind of fits better inside of an ML language. And I think that will be quite useful. Another interesting one is there's some work on effects tracking in OCaml, which I am both skeptical and excited about. Like, I think it could be good and it could be problematic. Actually, lots of the new things are interesting in that they open up enormous issues of like how do you design libraries, which are complicated questions, and then I think it'll take time to unwind. So like the language feature comes first and you learn how to use it later, sometimes years later. Actually, I think one of the fascinating, if you want to understand how people learning how to use languages develops, go look at like the implementation of a functional programming compiler from 20 years ago, and they're often kind of a mess. Like, they didn't know how to use a lot of the features that the languages themselves had, and like over time, people have come to understand. This goes back to the idea of like these languages in some sense feel like they were invented by mistake. Like, all the great things about them were not fully apparent at the time of their writing, and I think some of the things that are coming we won't know. Like, GADTs and first-class modules were a thing that landed recently, which I'm very happy about. The next thing that comes that I may be happy about may be not something I know is going to be good.
All right, let's thank Ron.